All right, guys, so now we've got this program working where we've got the low boxes going to the left, any high or medium boxes going to the right. You can see here that we've got sensors that keep track of whether it is a low or high box here. All right, so this one, the high box, we had high and low sensor, and again, both high and low sensor will be tripped again. Those are being kept track of in this network right here, where we've got the high box right here, and then low box will be tripped off on the next one. Beautiful. Okay, so we can keep track of those guys. The issue that we have so far is that we don't have a count of those boxes coming through. Let's take a look at our program, guys, and we're going to adjust our program to allow for a count of both high, medium, and low boxes. All right, guys, so let's scroll down here. Let's put in another network. We'll put it just above our outputs. So we'll click here, enter network. So network 10 will now be counter. Nice. Okay, so now we need some parameters to count up, right? So we need something here that's going to be a count up. Okay, we'll click over here, and then this needs a name here, so let's call this the box counter. Cool, and then we've got two inputs that are going to increment that up, right? So I'm going to drop this in here, I'm going to put another rung in parallel, and I'm going to have the same input, so when these go true, then they're going to count up this box counter. And we had the two memory bits, right? So we have %m0.4 for the high box, and then low box, I believe, was %m0.6. Beautiful. So those guys are going to both increment my box counter up. I'm just going to put an arbitrary value of 100 in for my preset value. It doesn't really make any difference at the moment. And then the current value has got to match with this one here. So let's go to File and Drivers and see where the counter is. So the counter is a QW30. So in a previous video, guys, if you want, you can go back to those other videos and see how we've built up this program so far. But we provided that tag of QW30 here for the counter. And if we go to our PLC tags, you can see that the counter is indeed an integer, matching with this one right here. Okay, and then just to double check things, we've stopped at the moment. We're going to click on the counter. We're going to click on configuration, and we just got to make sure it's configured as an integer as well. Okay, nice. Let's go back to our main OB here. So now we've got two inputs, memory bit 0.4 and 0.6, high or low box, incrementing our counter. That value is going to go to QW30, which is matching with our factor IO counter. And now we just need something to reset it. So here we're going to have our reset push button. So that's input, and we're looking for the reset push button. And I don't want it where I just press the reset button and it resets the counter. I want to have a timer there. The reason for this is because I'm going to make use of the reset to create another reset parameter network that resets all of my outputs. So I don't want it to reset my count. So if you've seen in the first video of this series, when I hit the reset, it reset the counter, and that kind of sucked. So I'm going to put in an on delay timer, and this guy is going to be called counter reset timer. Okay. And for this guy, I'm going to put in 3 seconds. So we're going to put in 3,000 milliseconds. So I've got to be pressing the reset for 3 seconds in order to actually drop this back down to 0 there. Sweet. Okay. I am already simulating here, guys. So you can see here that I've got my simulator rock and rolling. So I'm going to minimize that. I'm going to download what I just did. Okay, let's press play here. All of a sudden there was already a count of 1 from a previous portion of the program there. So let's see if this works, guys. So I'm going to scroll down here. Okay, and then I'm going to press this for 3 seconds. 1, 2, 3. Beautiful. Now I got it back to 0 there. And you can see that if I just tap the reset push button, so looking here, that when I tap it, it comes in for a couple of milliseconds. But if I don't hold it down for the full 3 seconds, 1, 2, 3, right, that's the only time that the output of the timer actually goes true and resets my counter. Beautiful. Okay, that way I can make use of the reset by tapping it and getting my outputs to turn off. Okay, let's keep track of this, guys. Let's turn this on and see whether it's actually keeping track of both the low, medium, and high. So at the moment, anything coming through is going to increment our counter. Okay, so that one's a low box. Nice. Incremented 1. Low box again. Nice. And a high box will be this one right here. Sweet. Looks good. Okay, I'm going to stop the line there. And then if I just tap this reset, then you can see that nothing's happening. But if I hold it down for 3 seconds, 3, 2, 1, nice. And then I can hit play and get my system back up and running there. Okay, so now we've got this reset here. We press it for 3 seconds and it resets our counter. Let's set up a reset parameter that we're going to make use of in case some of the boxes or pallets or something get stuck and we have to reset our outputs. So let's put that just below our left conveyor parameters. So insert network here. Okay, this is going to be called reset parameters. Nice. And what we're going to do is I'm going to have this where I reset it after I've stopped the unit. So we'll have something like if a pallet or something gets stuck, it's going to stop our system run from happening. So as long as the system run is false, then we can reset. Okay, the other thing that's going to take place is obviously we're going to hit the reset button. So this will be one where we just press it once. We don't hold it down for 3 seconds. So that was an input. We scroll down here, we'll find a reset push button. Nice. And then we're going to create a memory bit. And we're going to set this. And the parameter that I have for reset mode is going to be %m2.2. So I don't have that in there yet. So I'm going to rename this one as reset mode. And again, the beauty of having your tag table open is you can see sequentially what the next memory bits are that are available. And then we're going to put a parallel path in here. And then once that has reset, then we're going to start a timer. So I want the reset to take place over 3 seconds. So I'm going to drop this in. So I don't want to instantly reset everything. I'm going to create an on delay timer. This one's going to be called my reset timer. Okay, and this one's going to come in for 3 seconds as well. So instead of holding down the reset push button, I just tap this once. That sets my reset mode, which we're going to have to put here. So %m2.2. Okay, that's going to be true for 3 seconds, and then after 3 seconds, then we're going to reset the one that we put above. So we'll copy this guy and paste it here and change this guy to a reset. Okay, so again, we are in the negative system run, so the system run is no longer running. We hit the reset push button. It instantly sets our reset mode, which makes this true. That goes for 3 seconds as this timer is timing out. And after 3 seconds, then it will reset that reset mode. And we can make use of M2.2 on other networks. Okay, so we could download that, but essentially it's not going to change anything in our program yet. The next thing I'm going to put in is alarm parameters. So I'm going to add a network here. And this one's going to be called alarm parameters. Okay, and this one again is going to turn on an on delay timer. So I've got an on delay timer here. This one's going to be called my alarm timer. Beautiful. And I'm going to have this one for 4,000 milliseconds or 4 seconds. And then the output of that guy is going to be an alarm state. So I'm going to do %m2.3, so the next sequential memory bit. Haven't put that in yet, so I'm going to rename that as alarm state. And what's going to cause that to happen is if any of the sensors are true for 4 seconds, right? So if a pallet is stuck, it's going to be blocking one of these lights. So I'm going to put in a number of different sensors there to keep track of whether there's a block on the line here. So we have a number of different sensors. We have our pallet sensor. This one is going to be a normally open contact, so percent input 0.2. Okay, and then we have our other ones, and those ones are a different sensor. So the pallet sensor was an opposed sensing sensor. The other one was the at left entry. So I'm going to put a parallel rung here, and I'm going to drop this guy in. So if the at left entry is false, then it's going to, I mean, obviously false for 4 seconds, then it's going to turn on the alarm state. So that's an input, and I'm looking for at left entry. Okay, I want the same for at right entry. So parallel path. Same type of instruction because it's the same type of sensor. So at right entry. And then at left and at right exit as well. Okay, those are the exact same retroreflective sensor. So we'll put in 2 additional rungs here. And this one was at left exit. Okay, and at right exit. Nice. Okay, so if the pallet sensor, now the reason why the pallet sensor is different is that you can see that once the pallet sensor is there, then it's going to be true. Okay, with the other ones, if the pallet is blocking the light, then those will obviously be false. So I have different inputs here for the pallet sensor versus at left or at right entry or exit. Okay, so let's see whether that goes into alarm state. What are we going to do with the alarm state? Well, the easiest thing would be if something was blocking all the pallets from coming through, then let's turn off our system run, because our system run controls everything, right? So what we'll do is we'll come up here to our main line here, and we're going to add in a normally closed contact, and we'll label that as our alarm state. So percent M2.3. Looks good. So if any of those pallet sensors are blocked for 4 seconds, then we're going to go into an alarm state, and then this will be true, which will kick out our system run. And if we follow down to our outputs here, our system run is in series with all of our outputs there. Okay, let's see how that works, guys. Let's download that to our PLC. Okay, so we've reset everything. There's one thing that I'm noticing before we start, is that this right counter CV value is stuck at 4, and we don't have anything in our program at the moment to move a value of 0 into there. So I'm going to put a note to remind myself that at some point we're going to have to move a value of 0, so that when basically I think when Factory IO starts up, we want to move a value of 0 to reset this one here. Okay, so let's go to our reset parameters here. So we'll start everything up and running. Just make sure everything's cool, and that we got transferring left and right. Looks like we got counts coming in. Looks good. Beautiful. Okay, we can stop this at any time and start it again. Beauty. Okay, so what I'm going to do is I'm going to stop this here, and you can see that, let's look at our alarm parameters, that we're now in an alarm state. So the pallet sensor has tripped off this timer. We're now in an alarm state, and if I scroll up, my system run is now kicked out. Nice. And so all of my outputs are now off. Okay, so now let's take a look at the reset parameters. If we press our reset, then that sets our bit there, timing up for 3 seconds, and then resets. Looks good. But at that point, it didn't kick out our alarm state, right? Like say this box was in the way, we could move this out of the way, and obviously that took out our alarm state, right? Because it was no longer blocking that sensor there. But let's have something where the reset mode then kicks out our alarm state. So let's add in one instruction here, in that the reset timer is not timed out yet. So we're going to do reset timer, and we'll do the Q from that bad boy. Okay, we've made a quick change, so let's download that. Nice. Okay, let's see if we can get this up and running again. and then we'll see if that alarm parameter comes in. Okay, so let's reset our animation here. Let's start it up, and let's see whether everything runs properly. So you can see that that pallet sensor is tripped, but not for more than 4 seconds at any time as it goes through. At right entry and right exit seem to be being tripped, but the time that they are blocking that center is not getting to the total of 4 seconds. So that's good. Okay, so let's move one of these guys so that it blocks it. Okay, coming up to 4 seconds, and now we're into an alarm state. Nice. Okay, so we're in alarm state, which means that up here, our system run has kicked out. And let's scroll down now to the reset parameters and our alarm state, and we'll see whether by pressing the reset mode, whether we can change that alarm state now. So I'm going to move this guy off of the conveyor here. Okay, let's start everything up and see whether this runs now. Looks good. We're getting a count of each of the pallets that are going by. Looks like I might have to increase this to 5 seconds, eh? Because at some point it is tripping off my alarm state during normal operation. Okay, so let's see whether we can reset. Let's reset our counter now. So we're pressing this for 3 seconds, resetting our counter. Our alarm state is out. We can start the unit up again, and now everything's rock and rolling. So let's just watch this for a couple seconds, see whether everything's working properly. Looks good. Getting nice counts. Everything seems to be working properly. Okay, we're going to stop this here. This is timing out. Now in an alarm state. Again, going up to system run. System run has been kicked out. Outputs are off at the moment. Nice. And if we go back to our reset mode and alarm state, then we can press the reset mode once. Okay, once it's done timing, it will take out alarm state. Now I'm able to turn on my system run, and everything's back and running. Nice. And then if we're stopping here, and we're not blocking any sensors, and I wanted to at some point reset my counter, I can press and hold the reset button here for 3 seconds, and reset my count. Nice. Okay, let's get everything back up and running. Looks good, guys. Okay, so now we've got something we can keep track of an alarm state, right? In that at that point, we go into alarm state, all of our outputs are off, and now we've got a reset mode that we can then press. Takes 3 seconds to come in, kicks out alarm state, and then allows us to start the machine back up again. Nice. Okay, let's get some of these lights working now, guys. So let's get the stop light working, and let's get the reset mode maybe flashing during those 3 seconds of the reset mode. Oh yeah, and before we do that, if we scroll down here, then these values are set at 5 and 1 here. So if I wanted to reset everything at the startup, I should really be moving a value of 0 to each of those. So we're going to put in a parallel rung here. We're going to put in a move. Okay, so we've got a move function there, and we're going to move a value of 0 to our left counter, current value, and we're also going to move a value to, can you put a parallel rung here? No. Yeah, you can only move it once. Okay, so let's put another one here for another move function. Okay, and we'll move a value of 0 to our right counter, and specifically the current value. Looks good. Okay, let's download that. Okay, so now we can clearly see that left counter has a value of 1, right counter has a value of 5. So let's reset the animation here and see whether these guys go to 0. Nice. Okay, it looks good. And if we scroll down here to our outputs, we can clearly see that they're at a value of 0 as well. Okay, so let's throw in another network below here. And we're going to do outputs lights. Looks good. So the previous one was for our conveyors. This guy is going to be for our lights. And we can put in some stuff for our green, our red, and our blue light, right? So our start, stop, and our reset lights. So each of these push buttons can be illuminated. So let's do the green. So let's put that as any time that we're in the system run, then let's turn on the green light. So that one is an output, and we're looking for the start light. Looks good. So that's Q0.7. Okay, let's put in another rung here. And let's put in the stop light. So obviously if we are not in system run, then we're going to turn on the stop light. So that is an output again. Looking for stop light. Looks good. Okay. And then when we're in that alarm state, I want to have a flashing light. So I'm going to put this in here. So I want alarm states. That's percent M2.3. Okay. And then I'm going to put in this contact here, and I'm going to label that percent M60.7. Okay, and you can see that there's nothing there. I'm going to have this as a clock bit. Okay, so I'm going to bring this up and put this in parallel. Looks good. But let's keep in mind that, hang on, so, okay, I'm going to show you this in 2 seconds, but if the alarm state's on, I'm going to have this flashing at a certain frequency and having my stop light turning on and off, but this will be true and it'll keep my stop light all the time on. So when I'm in the alarm state, I need something to block this rung from being true. So I need the opposite instruction here. So I'm going to use my alarm state. So percent M2.3. Right? Otherwise, anytime that I'm no longer in system run, then it's going to just have my stop light on continuously. But I want this to be flashing on and off here. So the way that I do that is that I've got to set up the internal clock. So I'm going to come here, and I'm going to go to device configuration. Then what I'm going to do is I'm going to click on the PLC and go to properties. Okay, if that doesn't come up, you have to lift this up so you can actually see the properties there. And I'm going to scroll down to System and Clock Memory. Okay, let me make this a little bit bigger so you can see it. Okay, so what I'm going to do is I'm going to scroll down here and turn on my clock memory bits. So enable the use of the clock memory byte. Looks like I have to go offline to do that. Okay, so let's enable this guy. There we go. And then I can't use this because I've already used M0.0 through M0.6 for other things in my program. So what I'm going to do is I said that my clock was going to be M60.7, so I'm going to start this at 60. Okay, then I hit enter and you'll see that all of these change. And I said M60.7, so that means that that bit is going to be flashing at a half hertz. Beautiful. Okay, so now I'm going to have a bit that flashes at that frequency. Let me go back to my main OB here. Oh, it looks like I should have done that first. Let's go to tags and let's get rid of this tag because now we have a duplicate. Okay, now back to main OB. Now it's coming in. Okay, cool. I should have gone to system configuration first rather than making that tag. Okay, then I also want the reset push button. And if I am in reset mode was percent M2.2. Then I want to turn on a light. So I'm going to turn on my reset light. So that's an output. And let's scroll down to the reset light. Beautiful. So that's Q1.0. Okay. And I also want it to be flashing at the same frequency when I'm resetting for those 3 seconds. So I'm going to paste that bad boy in. And as long as my timer has not timed out, then I want the reset light on. So I need my reset timer, specifically the Q bit. Beautiful. And that's going to turn on my reset light. So let's take a look at what we just created here, guys. So if I'm in the system run, my green light is going to be on. If I'm obviously not in the system run, then green light will turn off. Then if I'm not in the system run, my red light will turn on, and as long as I'm not in the alarm state. So this will just turn on green light, red light, green light, red light, right, in terms of just on and off. Then if I'm in the alarm state, this will be untrue, so it will stop my stop light from being on continuously, but it will turn on at a frequency of a half hertz, right? So it's going to be flashing and causing this one to flash on and off. Looks good. Then down here, if I am in the reset mode, during the time that my reset timer is timing out, then I'm going to have this flashing, and this will flash my reset light for those 3 seconds there. Sweet. Okay, let's download this, guys, and see how that works. Okay, looks good. So everything should be set. Let's go into monitoring mode here. Nice. Okay, so we've got our red light on. Let's look at our outputs. Looks good. All the values are at 0. All of our outputs are off. Okay. So now let's hit the run button and see whether the start light is illuminated and whether this red light goes out. Nice. Looks good. Everything's rocking and rolling. If we stop at any time, then you can see that it just stops and starts, and we've got full green or full red happening there. Looks good. We'll stop this here, have it block that sensor there. Now we're in the alarm mode, and the alarm state came in, but it looks like the clock is not flashing at the moment. So what did I fail to do? What I failed to do was understand that was a hardware change. Okay, so I'm opening up this window here, and I'm going to right click on my PLC, and I'm going to download to my device, not just the software. So remember that up here you're downloading your software, but it didn't take in that hardware change that we did. So download to device hardware and software changes. Okay, so we're going to load these guys in. It's starting back up again, so we'll hit finish. Okay, let's minimize this. Let's move this over. Let's go monitoring again. Nice. Now we've got that flashing light now. Okay, so we're in the alarm state. Looks good. I'm going to hit the reset push button just slightly. Okay, we're now in the reset mode, and now we can start everything back up again. Okay, so let's see if everything works here. So we're going to hit the start push button. Looks good. Now we've got a green light rock and rolling. Then the red light. So those are solid lights, whether we're in the run or the stop mode here. Looks good. And then what we'll do is we'll stop this guy here. It's going to be blocking this sensor. We're going to go into the alarm state. There we go. So now we're flashing that we are in the alarm state. Beautiful. And at that point, I'm going to reset the unit. When I reset the unit for 3 seconds, the reset light will flash, and then I'll be able to start the conveyor system back up again. So pressing the reset button here, it's resetting to 3. Now I'm able to start everything up and be able to transfer left and transfer right. Sweet, looks good. And again, we still have a count of everything. If we were to stop it at some point, and then press the reset push button for 3 seconds, then it should reset that value back to 0. Looks good. I'm going to reset it one more time here, and then start the unit up, and we're rocking and rolling, and then we should get a nice clean count of every pallet that's coming through now. Okay, last thing, I don't know if it's last thing, but next thing we're going to do is we're going to need to throw in an e-stop here, guys, because when I click this e-stop, nothing's happening in my circuit there. So when I hit the e-stop, I also want to go into the alarm state and stop all of my outputs. Okay, so we've got our emergency stop. I was thinking of maybe putting it in here with the alarm state, but this takes 5 seconds to come in, right? We want this to happen instantaneously. So let's put something up here in line with our system run that the e-stop has to be in the closed position as well. So that's an input. We're looking at the emergency stop. Okay, so that has to be closed in order for our system run to be working. So if we take that out, then system run will kick out. That will kick out all of our outputs like we saw before. So then if we have created the emergency stop to be false, we also want something happen happening with the lights there. Maybe we can get that red light to flash as well if we're in the e-stop mode. So that would mean that we'd put a parallel rung here and say that when the e-stop is false, right, it has to be in series with this clock memory bit here. So again, that was input, what, 1.3? Okay, so if the e-stop is false, this will be flashing and my stop light should be flashing as well. So two things, it'll kick out my system run and then start flashing light. Okay, looks good. Okay, let's start up the system now. So we're now running. If we just hit stop, we're stopped. Good. If we hit the e-stop though, it stops everything and should be flashing that light there. It looks like this rung right here is still true. Right, system run is off. I'm not in the alarm state because I'm not blocking any of the sensors there. So let's put in the opposite instruction for that emergency. So percent input 1.3. Okay, let's quickly download that and let's see if that starts the light to flash. Beautiful. Okay, so I've now got my emergency in that my emergency stop is open, so this is true, so it's flashing the red light. Once I bring it back to normal state, then it just goes back to a solid red light saying that the unit is stopped. So anytime that I hit that emergency stop, it then flashes the light, and if we look at our outputs here, all of our outputs are off as well. Okay, let's put this back to normal. Let's start the unit up again. And then at some point where we're not blocking any of the light sensors, then we will hit the e-stop. Okay, so right there, flashing the light, looks good. It stopped all of our outputs here. And if we scroll up to our system run, we can clearly see that the system run is off. Okay, so we have to reset this and then start up the conveyor. Looks good. Let's stop it here. Okay, it's blocking one of those units. We're now in the e-stop mode and we're also in the alarm state here. Okay, so let's reset the emergency stop. Okay, so that signal is still coming in. Red light is still flashing because we are in the alarm state. So let's reset our unit, and after 3 seconds we should be able to start this back up again. Beautiful, and everything's transferring left and transferring right. Nice. So we got a stop start station in that we can stop and start the unit, and now we've got illuminated lights. And then at any point where we stop this unit and put the e-stop on, we have a flashing light to show that we're in e-stop mode. Take that out, and as long as we're not blocking any of the sensors, we can start the unit right back up again. And then if it were to stop here and block one of the light outputs, we're going to go into the alarm state. So once we reset the e-stop, we're going to have to reset. So tapping the reset, and after 3 seconds, 3, 2, 1, we have a solid red light. So now we can start the unit back up again, and everything's rocking and rolling. This one got blocked for a little bit more, so we've got to reset this one more time. Nice. Looks good, guys. Let's take a look and make sure that everything's still running nicely. Yeah, it looks good. And we still got a nice clean count of everything. And if we wanted to, we could stop this at any point. Let's stop it where it's not going to block any of the sensors there. And then if I press and hold this down for 3 seconds, then it's going to reset my counter there. Nice. I think we're good, guys. I think that's pretty awesome program. You'll tell me in the comment section whether you have different ideas or whether I've missed something. But I think from what I see, we've kind of accounted for a number of things happening there. And we've got all our lights and counters to keep track of that, whether we're in the alarm state or e-stop state there. Walking through the program for one last time, we have our initial network 2 here. So obviously network 1 is just the code that allows the two programs to work together. Network 2 was the one where when factory I/O was up and running, it reset all of our memory bits and then moved a value of 0 to our left and right counters there. Next rung was a start-stop to enable our system run. So stop has to be true, emergency stop has to be true, and we're no longer in the alarm state. That turns on our system run, and this keeps us in system run there. Then we've got our loading parameters. So if the pallet sensor is tripped, or if the loader is not busy, then we're going to set our loading parameters. And then once it's loaded, then we reset it. We had network 5 looking at high or low box. So the transfer of positive pulse from negative to positive set either the high or the low box here. Transfer parameters here were that the negative parameter of M0.0 was coming through, high box or low box was true, and then we are either transferring right or transferring left. And as soon as we did that, we reset the high or low box because it was no longer needed. Okay, then we found that once it was at right entry with the positive pulse, then we reset the transferring right, and again at left entry with a positive pulse, then reset our transferring left. Okay, the next one was in terms of loader busy. So if we were loading or if we're transferring left or right, we weren't allowing a pallet to come in. And then we had our right and left conveyor parameters, and that once we were transferring left or transferring right, it counted up the value. And then at the right exit or left exit, as long as it was above 0, then it counted down the value of our CTUD for either side. Our reset parameters were that if we were no longer in the system run, we could tap the reset. It set the reset mode for 3 seconds and then reset itself. And that reset mode was used in a number of different areas in the program. One that being that we made this no longer true, which kicked out our alarm state. Our alarm state was that if the pallet sensor at left entry, at right, or at left exit or right exit had a pallet there for more than 5 seconds, then we went to the alarm state. We saw with the alarm state it kicked out our system run and kicked out our outputs. Okay, then we had our counter. So high or low box incremented our counter up, and then to reset that unit, we had to press the reset push button for a total of 3 seconds to reset that value. And we're sending that value to QW30, which corresponds with our factory IO animation. Okay, then we had 2 last rungs here, guys. We had our output for our conveyors here. So entry conveyor was turned on when the system run was true, pallet sensor was not true, or if we were still in the loading phase. And to be our load, then we had the system run running and we were loading, so that kept our load conveyor turned on. And then system run was obviously in each of these rungs here. So transferring right turns on our output, transfer right, transferring left turns on our output, transferring left. And then as long as the count for the right counter or left counter is above 0, then that turns on our conveyor right or conveyor left, and again as long as the system run was in play. And then finally we had our lights. So as long as we're in the system run, we had the green light turned on. If the system run was untrue, or if we were no longer in the alarm state or the emergency was true, then we had a red light that was constantly on. And then the red light flashed on and off at a frequency of 0.5 hertz if we were in the alarm state or if the emergency stop was no longer true. And remember that this was a hardware change. We had to go to our system configuration to change that. Okay, and then finally with our reset light, if we were in the reset mode and the reset timer has not timed out for those 3 seconds, then again we're going to flash this at the same frequency, M60.7, to flash our reset light. All right, guys. Hopefully everything's cool. Thank you very much for sticking with me for the past 4 or 5 videos here. Hopefully you've been able to create a similar program. And if you have any other additional ideas or you think that I've missed something, then please leave them in the comments. All right, thanks very much, guys. Have a good night.